In this video, we're going to be finding the derivatives of exponential and logarithmic functions. And I went ahead and I added two more functions that are very important. So I'm going to put here and the square root of x and 1 over x. These are very important that you have to know by heart, along with the derivative of the trig functions and exponential logarithmic functions, because you're going to see them over and over and over again. So what's the objective? The objective is to find the derivative of exponential functions, find the derivative of logarithmic functions, find the derivative of 1 over x, and find the derivative of square root of x. And these here, I would like for you to memorize. Memorize them, so that way you're not having to do the power rule over and over and over again. So let's go ahead and look at some prerequisites that are required in order for us to continue. What is the natural log of x? And some people might say, sir, why is that ln of x if you're saying natural log? Why is it an L? Well, it really comes from I believe Latin, and Latin's like Spanish, and in Spanish you always say the adjective at the end. So for example, white house, the adjective is in the front and the noun is at the end, but in Spanish you would say casa blanca. So if you notice, casa is the noun, blanca is white, so therefore the adjective is at the end. So the natural logarithm is really, in Latin, is like Spanish, logarithmico, I don't know, logarithmico natural, which is going to be ln. All right, so what is natural log? Natural log is really just a log. It's just like any other log. And the log is what makes it special, what makes it natural, is that the base is the number e. And I did say number, it's not the letter e, it's the number e. All right, which is a transcendental number just like pi. All right, now what is the log base e of x? It's going to be ln. So instead of rewriting it like this, we're going to write ln of x, but these two are one and the same. Now, here's what a lot of people need to understand, that the natural log of e is going to equal to 1. Why? Because if I rewrite this, I'm going to have the log of base e of e to the 1. Now, what is that? That I don't know what it is, so I'm going to call it x. So then if I rewrite it using the exponential form, it's going to be e to the x is going to equal to e to the 1. So they have the same base, so that makes x has to be 1. So this has to equal to 1. So the log base e of e is 1. All right, so please make sure that you are aware of these two prerequisites. Now, this is everybody's favorite. I've been teaching calculus for many years, and students love the derivative of e to the x. The derivative of e to the x is e to the x. The function actually tells you the slope of itself at any particular point. So what a lot of people need to understand is, it's something that it's the easiest to memorize. What's the derivative of e to the x? The derivative of e to the x is e to the x, but it's really going to have an ln of e, but ln of e is just a big fat 1. So what's the derivative of e to the x? The derivative of e to the x is e to the x. All right? Now we come to a to the x. What's the derivative of a to the x? Well, a to the x is almost like e to the x. Wow, what do you mean almost, sir? Well, e to the x is really going to be 2.71, and it goes on forever and ever and ever, right? And it's going to have the power of x. So right here, my base is a number. So when I have 7 to the x, what's my base? My base is a number. Exponential functions have a variable in the exponent. Wow. So if you notice, here's an exponential function, here's an exponential function, here's another exponential function, here's another exponential function. All exponential functions have x in the power. So what's the derivative of a to the x? Well, if a to the x is like e to the x, and the derivative of e to the x is e to the x, then the derivative of a to the x, of course, is going to be a to the x, but is going to have to include the natural log of a Now this part does not disappear because a is not e. And remember that ln and e are inverses of each other. So what's the derivative of 3 to the x? The derivative of 3 to the x is going to be 3 to the x times ln of 3. Okay? So let's try some examples here. What's the derivative of this? So the derivative of this is going to be negative 3x squared. I use the power rule, plus 7 minus e to the x. The function here, e to the x, is the easiest one. I leave it alone. Okay? The next one, now the next one has an exponential, but it's not e to the x. So the derivative of 3 to the x, let me put here, dy dx, is going to equal to 3 to the x. But because it's not e, I have to put the natural log of my base, which is 3. Right? And then that plus the derivative of a sine, and the derivative of a sine is cosine of x. Next one. Well, I have 5 to the x. What's the derivative of 5 to the x? The derivative of 5 to the x is 5 to the x, the natural log of, times the natural log of 5, plus the derivative of e to the x is e to the x. And the derivative of a c is going to be negative, but there's a minus there, so it's going to become a plus. Now I have a coal squirrel, so I need another coal squirrel. And I need the Christmas tree. And if you're wondering what I'm talking about, you can watch the derivative of my trig functions and you'll understand. Okay? So that takes care of my exponential functions. Now we're going to take the derivative of the natural log functions. What is the derivative of ln of x? The derivative of ln of x is going to be 1 over x times the natural log of e. But the natural log of e are inverses of each other, so that this right here is going to turn into a 1, so I'm left with 1 over x. So the derivative is 1 over x. Okay? Now, please understand, ln of x is really a log base e of x. So this and this are the same function. So what happens if I change my base, my base here? Okay, and I believe I made a little mistake here. This is supposed to be 1 over, and this is supposed to be 1 over 1, which is really just 1, right? So the natural log is supposed to go on the bottom. So my answer really should be 1 over x ln of e. All right, I just rewrote it wrong. Okay, so let's go ahead and look at the next one. Oops, I did make the same mistake over here. So this should be, let me go ahead and correct this. It's going to be 1 over x ln of a. All right, so that takes care of that mistake. So what is the derivative of log base a of x? Now remember that the a is on the bottom, so this should be on the bottom along with the x. So let's try an example. What is the derivative? The derivative of log of base 3 of x. Well, that's going to be 1 over x ln of 3. And that is my answer. Okay, so let's try some examples of logarithmic functions. What's the derivative of log base 3 of x minus cosine of x? Well, the derivative, so let me put here, dy dx is going to equal to 1 over x, the natural log of 3, which I believe that I did on the last slide. And the derivative of a c is negative, and there's already a minus there, making it a plus sine of x. And this is my slope. This will help me find the slope of this function anywhere. So let's try the next one. What's the derivative of ln of x? The derivative of ln of x is going to be 1 over x. The derivative of a c is minus, so it's going to be minus 3. That's a Christmas tree, so I need coal squirrels, 2 of them. And I'm done. And then finally, the last one, I have a natural log and I have just a log with a different base. So on this one, I'm going to have my slope is going to be found by taking the derivative of ln of x, which is 1 over x. The derivative of this one, though, is going to be 1 over x, natural log of 5, minus, now, the square root of x. If I was to do the power rule, so let me go ahead and convert this to x to the 1/2 here. Because my root, let me see. Here's my 1, and here's oops, that's not a 1, that's a 2 here. And there's a 1 here. My root is a 2 and my power is a 1, so it's going to be written. So now that becomes 1/2 x to the negative 1/2. But then I shove, that negative tells me to shove it to the bottom, 2x to the 1/2. And that can be written as, okay, let me put here derivative. That can be written as 1/2 square root of x. So I would like for you, when you've been teaching Calc 1, Calc 2, Calc 3 for many years, you're going to find out that the square root of x comes out a lot. So the derivative of square root of x is going to be 1/2 square root of x. All right, so please memorize that. All right, now here's the derivative of 1/x. And this one, I can take the x, I can shove it up, it becomes x to the negative 1. I do the power rule, so that's going to give me negative 1x, subtract 1 from my power, and I'm going to get negative 2. But then I shove it back down, and it's going to give me negative 1/x squared. So memorize this one, the derivative of 1/x. Okay, please. The square root of x, which I had already done, the derivative of square root of x is just going to be 1/2 square root of x. So what are the things that I want you to memorize? Okay, the derivative of e to the x is e to the x. The derivative of a to the x is a to the x ln of a. The derivative of ln of x is 1/x. The derivative of log base a of x is going to be 1/x. And again, I have that same mistake, 1/x ln of a. All right, and the derivative of 1/x is negative 1/x squared. And finally, the derivative of the square root of x is 1/2 square root of x. So these are the things that I really need for you to memorize. All right, that concludes our video on derivatives of exponential and logarithmic, along with 2 more functions.